Good morning, CP Pre-Calc. Now what I did today is I posted the answers to the 3 problems that you guys had for homework yesterday. If you have any questions or concerns, please come to office hours and I can go over any of the concepts with you. Now what we're going to do today is we're actually going to work with the law of signs, but we're going to be working with something called the ambiguous case. Now the ambiguous case occurs when we're given 2 sides and a non-included angle, meaning the angle is not between the 2 sides. So this is my ambiguous case. Now what happens in a case like this is that we might actually have more than one possible triangle that can be constructed. And the angle that we're given helps us identify how many possible triangles we can have. So take a look at these notes. It says possible triangles in SSA case. Let A be an angle, A and B the sides we know. If A, meaning A is the angle we know. If A is obtuse, meaning you are given an obtuse angle. So if we are given an obtuse angle, that means that's the angle in which they give you. There are 2 possible things that can happen. If A being the side opposite the given angle, is greater than B, then 1 triangle is formed. If A is less than or equal to B, then no triangle is formed. So you can either have, if you're given an obtuse angle, you can either have 1 triangle formed or no triangle formed. All right, guys? All right, now we're going to flip it. Now what happens if you're given, now remember, these are for oblique triangles, and oblique triangles mean triangles without a right angle. So we're not even going to be addressing really a right angle case when we use law of signs, because in that case, if we had a right triangle, we could just use right triangle trigonometry, or we could use the Pythagorean theorem. So we're looking at oblique triangles. So that means you're going to be either given an obtuse angle or you're going to be given an acute angle. So if we flip it over, let me just make sure we can see. All right, if you're given an acute angle, so in this case, we are given an acute angle and the angle is not included between the 2 sides. Okay, so it's SSA. There's a couple of cases that can occur. All right, you can either, if in this case, you can construct 1 triangle, and that's if the height of the triangle is less than B, which is less than A. You can have 1 triangle. If the height is equivalent to A, you're going to have 1 triangle, and it won't be oblique. That would be a right triangle. If H is greater than A, you're going to have no triangle. And if H is less than A, which is less than B, you have a possibility of 2 triangles. All right? So if you have an acute angle, you have 4 possibilities that can occur. So again, if you have an obtuse angle, we're worried about 2 possibilities. If you have an acute angle, you're worried about 4 possibilities. And these are just diagrams of all the cases in which you can have when you have SSA, where the angle is not included between the 2 sides. All right? Now, what I want to say is there's 2 ways to approach this. I'm going to just concentrate on 1. We're remote learning right now. It's easier to just focus on 1. So in order to do that, I want you to cross out example 3. All right? And I also want you to say you don't always have to draw a picture. So you can cross that out too. You don't have to always draw a picture, okay? And I'll explain why. I want you to cross out example 3. And I want you to cross out example 4. All right, guys? It's a lot of crossing out, but I just think that concentrate on 1 method, and it's the method that I think is the easiest to work with, is the best strategy for our remote learning situation. So this is the way that I deal with the ambiguous case. So another way to deal with the ambiguous case, which is the way that we are going to deal with it, this is the way that we are going to deal with it. In example 5, this is our big way for the ambiguous case. Now, again, you're given an angle, and the angle is not included between the 2 sides. Now, what do I mean by included? An included angle would be angle C. C would be included between B and A because it would be made up, that angle would be formed by those 2 sides. A here is not included. That's why this is an SSA case. All right, guys, that's why we have an SSA case. So what we can do is when you have SSA, we can use our law of signs to help figure out other sides. Now, the difference between today and yesterday is yesterday I gave you 2 angles. So that 3rd angle was very easy to find. All right, in this case, it's going to be a little different to find that 3rd angle. Or, well, to find not just the 3rd angle, but to find one of the other angles. Now, the key is you want to find the angle first opposite the sides that you're given. So I'm given A and angle A. So I don't need to find any of those angles. So if I'm given B, my first goal is then to find B, the angle B that is opposite that side length. So we're going to use the law of sines to find angle B. So by using law of sines, I do the side length 20 over sine of 30 equals 16 over sine B. All right, guys? Now, by using law of sines, what we're going to do now is we're going to solve for B. But the difference here is, guys, B is an angle. We're not just solving for a side. So if I cross multiply this, I'm going to get 20 sine B equals 16 sine of 30. So I'm cross multiplying, and then I would have to divide by 20. So you're going to get sine B equals 16 times sine of 30 divided by 20. Now you're going to input that into your calculator. Now remember, when we put in the calculator, check that mode, make sure our mode is on degree, and it is. So I'm going to do, let me clear this, I'm going to do 16 sine of 30. I'm going to close the parentheses and divide it by 20. And I'm going to get sine of B to equal 0.4. So right here, but that's not my angle measurement. I mean, an angle measurement is not, that's the sine of B, that's the ratio of that angle B. So how do we find the angle measurement? Now, when we want to find angle measurements, we need to use our inverse trig functions. So let's remember. We use inverse trig to find angles. Angle measures. All right, guys, use inverse trig to find angle measures. That's what we need to remember. Use inverse trig to find angle measures. So I'm going to do, I know it's 0.4. That's the ratio. So I'm going to do second sine. I'm doing sine because I'm using the sine of B is 0.4. So B would be equivalent to the inverse sine of 0.4. So it is approximately 23.578 degrees. So that means right now, right here, what's my measure of angle B? It's approximately 23.578 degrees. Excellent. Now, if you take a look at that, that is one way to find B. That's one of my B's. But I said if I'm given what type of angle here? I'm given an acute angle. If we were given an acute angle, there are four possibilities here. We can have a right triangle, we could have one triangle, we could have no triangles, or we can have two triangles. Well, we already know I found a B measure, and that B measure makes sense because if B is 23.578, I can easily find C, subtract that from 180. That makes sense. But there's a possibility of a second triangle. Well, let's talk about our quadrants. We got quadrant 1, 2, 3, and 4. And what we know about our quadrants is, when I think about it, we talked about where our trig values were positive. In quadrant 1, everything was positive. All students, sine was positive. Take, tan was positive. Calc, cosine's positive. We're saying the sine of B here. Sine of B is 0.04. That means our sine is positive. Well, sine is positive in two quadrants. I could have a value in quadrant 1, or I can have a value in quadrant 2. So there are going to be two angles that have a sine value that is equivalent to 0.4. So how do I find that second one? Well, look at our quadrants. And this is obviously 23 degrees is in quadrant 1 because it's between 0 and 90. To find the angle in quadrant 2 that would have the same reference angle, 23.578, what we would do is we would find the supplement of that value, because the supplement of this value would be the angle with the same exact sine value in quadrant 2. So if I take this, if I just want to find the supplement, I'm just subtracting this 23.578 from 180. And if I do that, I'm getting 156.422 degrees. Meaning if there was a second triangle, that would have to be the measurement of the angle because those two angles have the same sine value. But wait a minute, does this make sense? And it says, why not? Well, why doesn't it make sense? Well, let's remember, we're still constructing a triangle. It has to construct a triangle. And the sum of your interior angles would have to add up to 180. If you had an angle of 156 and another angle of 30, those would be two angles in your triangle. But wait a minute, the sum of those two angles is greater than 180. So therefore, could this be a triangle, an angle in your triangle? No. Does that angle B make sense? And the answer is no, and it's because 156.422 degrees plus that 30 would be greater than 180. And we know that a triangle has to have exactly 180 degrees. So what's my conclusion? In this conclusion, that I only can make one triangle. And that the 23.578 degrees would be the only possible measurement for angle B. All right? Okay, guys, let's flip it over. Okay, let's take a look at example 6. All right. So if we take a look at example 6, we have this triangle, and it says, example 6, given a triangle with given a triangle at measure 30, where A is 7, B is 16. Find the other dimensions. Use the law of sines. All right, well, let's take a look at this. I have an acute angle. So if it's an acute angle, I have a possibility of 1, 2, none, or a right triangle. So one right triangle, one triangle, I could have, when I say one triangle, I mean one oblique, which would be non-right, 2 oblique triangles, or just no triangle. So we want to see what happens. So again, we're going to start by finding the opposite angle that we need to know. So like if we take a look at this, we know A is 30, and I already know that A is 7. So that's part of my law of sines. So what I'm going to do is use the opposite angle from the other side, which if I have B is 16, I'm going to find angle B. So if I think of this, I'm going to say, I know that 7 over sine of 30 would be equivalent to 16 over sine of B. So we're using the same exact method that we used in the last problem. So guys, let's take a look and see what happens. Now, let's evaluate this. I know I have 7 sine of 30, and I have this. So I can cross multiply. I can do 7 times sine of B is equivalent to 16 times sine of 30 degrees. And then I can divide by 7. These 7s are going to cancel out. So I'm getting sine of B equals, now let's put that in our calculator. It's going to be 1.143. Now remember, to find the angle measure, we need to do inverse sine. So I'm going to say B is equivalent to the inverse sine of 1.143. Okay, let's put that in our calculator. So I'm doing the inverse second sine, gives me inverse sine, 1.143, and I press enter. And I get, wait a minute, I got an error. I got an error. I didn't plug anything in wrong. And I'm hoping maybe some of you can recall something we learned about sine. Sine has a restriction. It has a max value and it has a min value. So we have to recall, in this case, B, this does not exist, this value. And the reason it does not exist is because sine of an angle has to be less than or equal to 1 and greater than or equal to negative 1. If I look here, this 1.143, I cannot take the inverse sine of that because sine has to be between these two values. I would never have an angle measurement that I can put in for sine that would result in a value of 1.143. So therefore, this does not exist. If I can't find an angle B, I have no possible triangle. So if you get stuck with a sine value that is out of the sines, in this case, out of what you can take the sine of, the inverse sine of, then you have no possible triangle. with the angle measurement 30, where A is 7 and B is 16. All right, guys? Okay, let's look at example 7. So if I look at example 7, again, we got an acute, right? I got an acute. And again, we're finding B because we're given angle A is 30. I'm given A here is 10. Here I'm giving B is 16, so I want to find that B. All right, guys? So let's take a look at that. Same strategy. We're doing 10 over sine of 30 equals 16 over sine of B. All right? So if I take a look at this, what I can do, again, cross multiply, same strategy, 10 sine of B equals 16 sine of 30. And then we are going to divide by 10. So we're getting sine of B equals, let's put that in our calculator. And if you put that in your calculator, you should have 16 sine 30 divided by 10. You should get 0.8. And guys, that's a good sign, because if I have 0.8, I know it's possible to get the inverse sine of that value. 0.8 is within the domain, within my restriction here, between -1 and 1. So therefore, I can do inverse sine. So I'm going to do second sine to do inverse sine 0.8. And you're going to see, you're going to get a measurement, 53.130. So I know that B is approximately 53.130 degrees. This is what I'm going to call case 1. Now we need to then find, for case 2, you need to find the supplement, just to check it. So we need to find the supplement. How do we find the supplement? I take that 53.130, I take 180 minus that answer, and I know my supplement is B being 126.870 degrees. Now check, is that possible? Now before, in this one over here, it was not possible because 156 and 30 added up to more than 180 degrees. Is it possible here? Well, let's look. Well, let's see. If this is A, now, if I know two angles, if this is 1B, that's A to find C. Well, let's find C in case 1. In case 1, all right, C in case 1, I would take 180, subtract the measurement of that B, 53.130, and then subtract A, which was given, which was 30. 96.87 degrees. So this is 96.87 degrees. Here we have 3 angles that add up to 180 degrees. Now to find C, we use this C value. So I would say A, which is 10 over sine of 30, because these are the 2 easy ones that I was given, would be equivalent to C over sine of 96.87. Now, if you would put that in the calculator, I would first take 10, divide it by sine of 30, and get my answer, and then multiply it by what would be in the denominator here, which would be sine of 96.87. And I would get C to be approximately 19.856. So these would be 3 measurements of one possible triangle. But we said we could have 2 possible triangles. So now let's check the supplement. Can I get a C value? Let's see. Now in this case 2, I would say 180 minus B in my second one, which is 26.87. That's B for case 2, and minus 30. I would get 23.13 degrees. A C actually exists within my domain. So if I look at this, I say all these 3 angles can add up to 180. So I'm fine. I needed 3 angles in my triangle that can add up to 180. So now I have to find a different C value though. This C value is across from 96 degrees. That's one possible triangle. The second possible triangle has a different C angle. So therefore, we would have a different C length. So the difference here, when I plug this in, instead of doing 96, I'm doing that 23.13 degrees. So if I plug that in, I'm getting, in this case, 10 divided by sine of 30. And then I'd multiply it by that sine of 23.13. And I'm going to get that C to be approximately 7.856. So I would have two possible triangles. This would be triangle 1, and this would be triangle 2. All right? Now, what you guys are going to do for homework, and remember last night I'm posting A, B, and C from today. Your homework tonight is going to be D, E, which you can't see the E, and F. All right, guys? D, E, and F. There are 3 cases where you're going to be using the ambiguous case. If you have any questions, I need you to come to my office hours. They're same as always. So in the morning, it's 9:15 to 10. And in the afternoon, it's 2 to 2:45. Please come with any questions you have. And I hope to see you guys at office hours. Have a great day. Bye.